All right. Thank you, everyone, for joining us today. My name is PJ Stevens. I'm one of the marketing managers here at SmartBear. Really excited to be bringing you this presentation on eliminating your dependencies in your UI testing, how virtualization makes unavailability a thing of the past. So today's presenters, we've got Dan Giordano, our product marketing manager here at SmartBear. How's it going, Dan?
How's it going, guys? Good morning or good afternoon at this point.
And also we've got Nathan Wright, one of our solutions engineers here at SmartBear. Hey, Nathan.
Hi, everybody.
So these guys will both be walking us through. They've got a really exciting presentation and a really cool demo at the end. So before we get started, just want to run a couple of housekeeping items, some FAQs that we usually have. Yes, so this session is being recorded and we'll send it out via email later this week, so stay tuned for that. If you have any questions as we go, definitely don't hesitate to use the Q&A box here in Zoom. There's also a chat box, but we'll be looking at the Q&A box for any questions, so make sure to use that one. And at the end, we'll be demoing Service V. So if it's something that you're interested in checking out a little bit more about, feel free to visit smartbear.com/servicev, and it is available as a 14-day free trial. So definitely check that out if you get a chance. And before we dive in, we're going to run a quick poll question here. So let me pull this up. And so today's question is, what slows you down the most during UI testing? Is it test creation, data management, testing dependencies, or a lack of tooling? So I'll give everybody a second to respond here. Interested to see what people have to say. All right, we'll let this run for 5 or 10 more seconds. Thanks everybody for participating here. This just helps give us a good idea of the audience that we're speaking with today, and try to cater the session around that. So I'm going to end this in just a second here. All right.
Yeah, it looks like we picked a good topic too.
I think so. Yeah, pretty interesting. All right. So let me share these results here. So Dan, what do you think about this?
Yeah, our winner today is testing dependencies. So definitely a cause for concern about the slowness of our testing. So good thing we have today's topic coming.
Awesome. Cool. All right. So with that, I'll let you start to run us through this presentation.
All right. All right. So today's application architecture is modular. It's modular in nature. That means you have the central UI, you have your central application that you're hitting on the UI side, but it's made up of many different parts on the backside. So the data and the functions behind that UI are made up of smaller components. You see here, we have things like Amazon Web Services doing our compute and storage, Twilio, maybe communicating with clients, Stripe, payment processing, Google Maps, helping locations, and some databases hooked up here. This is what a modern application looks like today on the back end. And all these different services are making up that kind of front side UI that you're testing on a daily basis now. And at the end of the day, applications are connecting all of this. So what is an API quick? An API is just, it's an application programming interface, and it allows one piece of software to make use of the functionality or the data of another piece of software. It provides a consistent programmatic method for accessing the resource, and it's been standardized today by protocols such as SOAP or HTTP REST JMS. And it allows, as we see here in the graphic, a database or service, again, a function, to communicate with that middle layer, that API, and then produce a response in your application. And with the way that the world has gone and software has gone, service-oriented architecture is everywhere. You can see here we have our mobile application that might help us cancel a credit card or view a balance. And there's absolutely all these dependencies on the back end. They're prevalent at the presentation layer, making up that UI, but they're also most prevalent at the logic and the system layers. So it's helping, it's providing that logic layer between the data itself and your UI. So there's a lot of things happening in that middle piece. And today we're going to talk about some questions like, what if they aren't all available at this time? You can see here, this is over 10 pieces of dependencies that all need to be working together. On average, organizations have something like 33 dependencies on each piece of software. So that's just a lot of smaller APIs and components making up that UI, and kind of giving you that challenge that we'll talk about. And then also, what if these APIs are third party? What if we don't own them? That also presents itself with its own unique set of challenges.
I'd also start thinking here if we were adding functionality or we were building out a new integration with some other API that potentially isn't fully completed yet, having, well, we'll get into it, but there's definitely some different ways that we can start to use the virtualization component on top of all of these.
Exactly. And then this is all taking part as we're trying to shift left. Shift left is huge in quality assurance organizations and development organizations across the world. It comes up with our customers, with our clients we're talking to consistently. And system availability during this all is crucial. It puts this mentality with a lot larger focus on the testing earlier in the software process. It successfully can limit the defects found kind of in your test and operational phase, which you can see from this graph. Bugs are much more expensive when we find them there. Bugs are often the cheapest when we find them in design and the development stage. So shifting left is providing us with this opportunity to test earlier, but because of that, system availability is absolutely crucial. And that's something that as modular APIs become more prevalent in our applications, we're going to be waiting on those systems to be ready. So with the shift left, what are these challenges that have presented us on the UI side? First one, and I think service virtualization fits in perfectly, is the unavailableness of the internal or third-party services. What happens if all these underlying APIs are not available to hit? What happens if they're only accessible at certain parts of the day or maybe certain times of the week? Or maybe they're not even yet built. That kind of negates us from being able to test that UI, even if one piece of the API is missing. Let's say UI has 10 different APIs making it up. If we're missing just one, that UI is not going to look right. Our UI tests, our UI functional tests are going to fail. So having a modular application architecture is presenting that challenge for UI testers. Also, data configuration and management. Getting testable, configurable responses from third-party APIs or maybe even internal APIs that you don't own is very difficult. Think payment processors or external data sources. It's difficult to get an error response when you can't break the API on the other side. How do you manipulate this data? That has been a big challenge for UI testers going forward, and you'll see that service virtualization has an answer for that as well. And then finally, internal and third-party testing costs. Oftentimes, end-to-end and performance testing simply can't happen because of the cost of the back-end token. So let's say we're testing a form and we'd like to load test that form. Well, if that form is hitting a live API that maybe is costing us something, or if it's going into a database like Salesforce or a marketing automation tool, we can't really load test that and bring 100,000 virtual users into that. It's going to cost us a lot of money. And you'll see again that virtualization can help us there and decrease our actual capitalization costs while we're going through the testing process. So overcoming these challenges with service virtualization. So service virtualization is a method to emulate the behavior of specific APIs or web services in modular-based applications that reduces system dependencies. So we're enabling ourselves to parallel test and development. We're allowing earlier testing and we're reducing those testing costs by actually virtualizing the API and mirroring it. So we're not going to hit the live API, which we'll go through in the demo, but we're going to be hitting an exact replica with real dynamic live data without incurring some of those costs. So you can see here, system end-to-end integration testing, performance testing, they often happen too late in the SDLC because there are just too many interdependent services needed. You can see here, this is a UI for our cross-browser testing tool. It has a login account. This is something where you log into the account using something like Selenium or a test complete type tool. And we'd be actually hitting 4 different APIs with this one UI. So once you log in, our MySQL database actually holds all of our customer data. Our Mongo database is going to collect all the events that are happening. We have a security layer, which is an expensive called API in between as well with each login. And then we actually have an email abuse engine as well. So if someone is giving us a ton of junk emails, this API should actually stop this from going forward. And all of this would be needed to actually run a UI test. So all these would need to be live. They need to be actually running. And that can only happen at later stages in our actual development process. But if we virtualize all this, each of these services can be ready to go and you can test them earlier in the process. So all 4 of these easily we can virtualize with Service V Pro, which is our virtualization tool we'll be looking at today. We'll be actually seeing the insides of it. But virtualizing these 4 can help you run end-to-end tests, performance tests, longer UI regression tests as soon as your sprint starts. So you're not waiting for the last 2 days of the sprint or maybe the last 2 weeks of a 6-month-long project. You're actually able to test the first hour, the first day of that sprint of that project. And you'll see here, just to reiterate, this is your typical test staging process, right? So your development, you have a 2 to 4 week window maybe of building these 3 different components that make up application D. So your development team will be in their silos working as hard as they can to kind of make these components available for you. After 2 to 4 weeks, the QA team usually gets involved during this integration testing phase. And even when the integration testing starts within 1 week, you might not have all your services available. So you'll see here, 5 weeks have gone by and we only have 1 component ready to go. And we have another one maybe that is almost ready to go with 1 not available at all. And then after that 1 week goes by, so now we're 6 weeks in, we're trying to do our end-to-end testing because we're getting pretty close to launch date. And we're still lacking in total component structure. So we only have 2 out of the 3 that are needed. And we're trying to run performance tests. We're trying to run user acceptance tests before actual customers get the application in their hand, which makes that missing component it's a huge drawback for us in this case. And then once we're in production, we actually have all of our components done. So let's say that component B is a third-party service that we're just never going to have complete access to, or at least live access to, until it's in production. With Service V, we can virtualize all these components, and you can see you'll actually be able to run the end-to-end testing, the load testing, and the integration testing right away. So here, 2 to 4 weeks, once the actual spec is mocked up, once that API is actually designed, we can go right from there, start virtualizing that API, and then running tests against it. Maybe it does take 2 to 4 weeks to actually get some of the services built out that the dev team really needs to work on. Well, even then, we have the ability to virtualize maybe that third-party component or that component that's still not ready, and we get a really full application that we can do end-to-end tests against. We can do load testing. And again, this is happening 2 weeks, 3 weeks, 4 weeks before it traditionally would.
And this is a pretty cool idea. We could even take something like this and say, let's virtualize that production environment the way that it is going to look when we finish it. Let's write our tests against it, and then we hand it off to the development team. They could actually utilize those tests. We could validate through something like an automated pipe the code that they generate and write, and we don't have to, shift testing or have testing be kind of this crunched in thing at the end.
Yeah, every time they're checking in code, those test cases are already written against the API and that final full application. So they can actually, you can get this measure of end-to-end testing the first week when the developers are actually laying down their first bit of code.
Yeah, as it's being written. It's a pretty cool concept.
Then owning third-party APIs, I think, is something we're also talking about here. It's difficult in this transaction case. Let's say we're sending a payment to a payment processor. That processor is actually declining the payment. So on our own UI, we're asking the customer to edit that card information. We're saving that card information in our own CRM. And then we're actually sending that payment once it's saved. Now that payment processor is going to accept the payment because now it's passing. And we're going to send out of our own system an email receipt. Now, this whole transaction process here, it involves 2 external APIs and 1 of our own. But this is something where getting this payment decline information back is something difficult. You can't always have access to that API. You can't give it its own failure states or its own passing states. That's kind of their own logic that they own on their side. With virtualization, we can actually own that logic. So we can virtualize all 3 of these services, And this back and forth of request and response and the actual transaction can be controlled completely by us. So all the data is customizable. We can say when this credit card number goes in, this should be a failure, and then we can actually sculpt what that failure looks like in a lot easier manner than if we were just blindly testing against a black box service like PayPal or like Stripe. Now, some of you may be saying, I've heard about this. This kind of sounds a lot like mocking. And we just want to kind of separate the two, because while mocking is kind of advantageous in a small, unscalable way for development teams, virtualization brings that power to the entire org. So mocks in general are hard to create. You need scripting experience. We'll go through and see that virtualization, you don't need any technical experience. Service vPro is very easy to use. Often owned by other teams, lack of control. Developers are making their own mocks in their own kind of world, and it's hard to share. Service V has a module called Vert Server that you're able to share your virtual APIs across a cloud, on your own local infrastructure, but you can generally share it across teams very, very easily. Also, mocks are static. They're limited to a few scenarios, and they're hard to create multiple responses for each scenario. Again, with service virtualization, you're going to have full dynamic data, or you can at least. You can mock up your own fake responses quickly by copying just data over and over. You can also hook up a database directly to it. You can import a CSV, and you can actually drive data through that virtual API. And then again, stateless, cannot easily pass parameters. Everything that we're doing in virtualization aspect is dynamic and living and breathing, much more so than mocking. So just to recap here, what service virtualization is bringing us, it's bringing us the increased delivery velocity. You're able to actually test and develop earlier on in the SDLC against those APIs. It also improves your application quality. Running end-to-end tests, integration tests, and performance tests much earlier should help you reduce the cost of bugs and defects. You should find more bugs as well. So one of the things that actually teams just won't run load tests against the final application, or they won't run full end-to-end tests when they know that just that API isn't going to be there. And now we're kind of taking away that excuse. The ability to run full end-to-end tests against an accurate system is now available. And then we're reducing testing costs. We're allowing team members to test mission critical APIs and services at any time, at any rate. So we don't have to worry that maybe Stripe costs 2 cents per call, or that we only have 25,000 free calls of Google Maps. The ability to actually develop and test around those APIs that are accurate and living and breathing without incurring any of these rate costs or anything is huge, again, both on the development side and the testing side. And then Service vPro benefits the entire org. So it's not just testers really, but it's the development team, it's the QA and testing team itself, and also infrastructure teams. Developers will be able to eliminate the need to create stop-the-mock services. We talk to clients that take 6 weeks to a month or to 2 months to actually build out the mock API, and then the test team can start working on it. And then that development team will go back again and for another 2 months actually build out the real API. So that's 6 weeks to 2 months of work that just doesn't need to be done and is costing us time to market with our features. With service virtualization, we can eliminate that. We can also create services that are shareable. One of the things that's a pain in the neck, I think, for developers in mocking is they're constantly creating their own mocks with their own dummy data. We can actually have one person do this and share them out to teams. You can mock APIs in seconds. We're not going to go through a ton of prototyping with Service V, but just know that it is totally possible with Service V to create a RESTful service from scratch. You have the ability to, through a wizard, actually create endpoints and then create the data that you'd like associated with those endpoints and parameters. And then also it reduces dependencies on other developers' finished services. So not only do testing teams feel this crunch between actual assets not being available, but so do development teams themselves. Developers need to use different services and they're not able to. Service virtualization for testers. It's helping write test code before the service is even running. We talked about that a little bit before. Before that service is deployed to an actual server, you can write test cases against that API and get ahead of the game a little bit. It also helps us reduce dependencies on system availability for those longer end-to-end tests, the performance testing, and kind of those regular functional tests that we're not doing maybe right now before that last day of the sprint or the last 2 weeks of the project. And then load testing here, talking about again, just because again, it's something that's cutting our costs down and allowing us to shift left with the performance and do much more load testing on not only the UI, but even some smaller chained APIs. And then infrastructure real quick as well. It provides a light, affordable environment at scale. Something that infrastructure teams are working with microservices is constantly providing these uptime services for tester development. Service virtualization takes that need away. It kind of gives them this quick way to replicate systems, and it eliminates complex solutions for legacy service availability as well. So let's say you have a team of 10 developers and they need access to 25 different dependencies in their own little test environment. Some of the legacy services can be really difficult to replicate for each one of those 25. I think hitting a legacy database with a load test or even with functional tests on a constant basis can be dangerous for actual production performance. So it eliminates the need to do that, and you can just virtualize it. And then reduce unplanned, expensive third-party transaction costs. Hitting again that with the rise of SaaS and kind of SaaS connections within our own application, we have the ability to actually cost our companies a lot of money running these end-to-end tests, performance tests against live APIs. Virtualizing it virtually eliminates the entire cost there associated. All right, now after this, we're gonna jump actually right into Service V Pro. So our demo. Nathan, if you want to share your screen, you can take over.
Perfect.
Fantastic.
So to kind of bring what Dan's been kind of going over full circle here, we have a little example, a little kind of demo project or environment that I've set up. And the story here is that, let's pretend I'm a developer. I'm working on a front-end application that integrates with an API. The API runs, maybe we pay, some service to host it for us. It's a third-party API or something like that that we utilize to render out data. In our case, when we look at the application, very straightforward. It's essentially taking statistics and information and rendering it out on the screen. So in our case, we just pick a couple of values, an API call runs, and we see we get all of the data back that the service kind of shows on the screen here. So each one of these different buttons is just a different API call. In this case, the API serves up essentially game data, week data, and we eventually get down to these actual kind of statistics. And these all come back as JSON from this API. So when we look at the underlying application code, there's not a whole lot going on here. We have two methods that have been created, top and bottom there. These are really the only things that drive the web app that we were just looking at. We're kind of making a call against this API based on a specific week, and then we're asking for a specific value based on an ID. So this is a good example of, maybe I'm working on this application, we're building out the styling or something, changing the way that this renders. And I get word that the API is going in for some work. They're revamping the database that it feeds off of. Maybe it's like the off season in this case. We don't have anybody actually using the site, so we can pull the API down and start to make changes. It really throws a wrench in my workflow. What am I going to do now that I don't have that actual API? And that's really the basis for all of the data that we see on the screen. It's nothing more than just a nice way to show a bunch of data that came back in a JSON format. So this is a good example, again, of where we want to start thinking about virtualizing. I know what data I need to show on the screen. I know how I want it to be structured, and I also know how I make the calls. So I can use that information to essentially mock out all of the interactions that this app would potentially make against this service. Now to do that, we're going to jump into Ready API. And we can see that because I am a very methodical front-end developer, I've also written in some back-end tests. So this is essentially just a definition on the left-hand side of all of the resources that we use in that front-end application. We can see that there's that games resource, the games-ID, which gives us specific value. And that's all defined here within Ready API. And we can see that on the left-hand side of the screen, we run a request, we get a response back. This is the data that we're then kind of parsing through and rendering out on the screen. And again, this is the data that we want to start to think about virtualizing. So because I have the service already defined, all I have to do within the tool is to right-click, select this Generate Virtual Service option. This is going to bring everything over into Service V. And we'll see that the tool is very straightforward. It's essentially broken down into 3 columns. We have the request that we're listening for. In this case, it's the method and just the short resource. On the right-hand side, we have the different responses we could potentially return. And in the center here, we have the logic that defines, okay, based on some value in the request, which of these responses should I be returning to the client? And, you know, as we mentioned, we could manually go through, like, copy paste responses into some of these fields and build out this application. Because I know that that service is going to be taken down in, let's say, a week, we can actually use that existing service to build out all of the values that we would really need to facilitate that front-end application. So I think that that's the workflow we'll go with today. And then maybe we can look at some of the other avenues that you could potentially use to create services in Service V. Cool. So let's just clean up some of these responses. These are just placeholders from previous calls. And then right up at the top, there's a little setting that is called our route options. This is going to define how we handle requests that the tool hasn't seen before. When we set this to route and record, we point to the endpoint that we want to forward our traffic onto. In our case, it's just something running locally on our network. And the tool is going to listen for requests on these specific paths. If it gets one in that it hasn't seen before, it's going to forward it on to this endpoint. It's going to capture the response from that service. And then as that comes back, it's going to store it here within the tool. We'll see it logged on the right-hand side. It's also going to create the logic that says, okay, why did we serve up that response? You know, what value in the request defined that that was what we needed? And so it's going to do a lot of the legwork for us in standing up one of these mock services or virtualized services. Let's go ahead and just turn a couple of these on, make sure it works. There we go. And we'll just record all of our responses here. Great. So now we can see right up at the top, this has a local endpoint. It's localhost 8088. I'm going to set this to run. And the action that I expect to happen now is for us to be able to run a request from the back end of our, from the code in our front-end application. We should be able to make a request now against this localhost 8088. As these requests come in, as we click around on different buttons on that web page, they should be getting forwarded on to the existing services, and it should be storing their responses as they're given back to us and returned to the client application. And in this way, if we were to click the same button twice, we actually would only be reaching out to that existing service the first time. So let's go ahead, let's jump in, and we should be able to just update a couple of lines of our code here. There we go. I think it was localhost 8088. Just go ahead and save that. Let's restart our service. This might jump the page. Great. So once this loads up here, just take a second. We know that we just changed the application to make a call against localhost 8088. Now, when we click any of these buttons, we're still getting data as if we were hitting that actual API. And we can look back in Service V now, and each of those calls has been tracked. So if we were to click that same button sequence again, all the data now is coming back from that mocked API. And we can see that we've received and sent 8 different calls but only 8 of them in this case, or sorry, only 4 of them in this case were actually forwarded onto that other endpoint. And this works with a lot of depth. So we could be making a whole series of different calls here. We could have a front-end test that is iterating over everything that's rendered on the page. And when we look back, all of this data is starting to be captured. Now, of course, we can define how much of this and at what scale we should be recording all of this traffic. But just as a very simple example, I think it's obvious how easy and how useful these mock services are, these virtualized services are. Essentially, now we will be able to stop this service, turn off any of this routing. Everything now is stored inside of the application. So when we look at each of these weak options, the data is there. When we look at the logic in the center, the rules that got that, in this case, it was just a single query parameter that returned that value. All of this has been created. And so now from our application, we could reload the page. We could be selecting our different weeks. And again, none of this data is actually coming from the API. This is all coming from that mock service. So really, really powerful, and hopefully a good example of how we can completely strip away that dependency on an API that might be out there. So yeah, there's plenty of other features that we could definitely go into. Dana, I don't know if there's anything that you kind of wanted to mention at this point.
No, I think that was great, and I think it's a great example of just seeing how you can manipulate the back end of the API. Can you change data and swap it on the UI side itself? I don't know if React compiles live time.
Yeah, so let's say I'm trying to think of what we could potentially change here. Let's say that we changed.
Could we change the name of maybe the Patriots?
We could do that. This is where I wish we had a Control F function in here. Let's just grab this first one. So this is Nathan's amazing team. And let's say the away team was Dan's subpar team. No offense.
No, it's okay. None taken.
PJ, you dodged a bullet on this one. Now notice that we never restarted this service. It's still running. We jumped in here, made some edits. But now, hopefully, if this worked correctly, we should be able to reload our front end app. We should be able to make a call, and look at that. That data that we swapped out is shown to us right in the browser. So very easy to change things out, to force something like Dan was mentioning earlier. If we want to force an error now, let's maybe say that we led with an exclamation point right here, which is terrible when we're trying to write some scripts. But for whatever reason, maybe that's the way that this team or the API responds. We need to be able to handle that with the front-end application. And I could actually force the service to respond in that way and make sure that my front-end app is actually handling that, parsing it out correctly, either returning or kind of throwing in an error, depending on how we want to script that out. But yeah, obviously a lot of ways that we could now build on top of this.
One quick thing, because it's coming in question, could you show us the discovery method real quick?
Oh, yeah.
And just maybe hit a live website and see how you can record that traffic from the API. You can do either a website or an API itself, but something to show how easy our record and discovery features are.
Absolutely, yeah. So as Dan mentioned earlier, there's a number of different ways that we can get started. We can do it through this route and record action. We could treat this as like a sandbox environment where we can kind of manually say, okay, these are my resources and responses. We can also use what we call a discovery feature. Now we need to define what type of service we want to record. In this case, it's going to be a RESTful call. But we'll find that we can open this up. We can either run this as a proxy. So if I have like a test suite or something that's going to execute, or maybe we just want to run this and kind of perform an action through the browser, like logging into a service, getting a token, making a series of calls there. We could definitely run this as a proxy just for ease of use. Let's just run a request against our own website. Now this is an interesting use case. This isn't an API, obviously. This is a fully fledged application. But what's happened here is that we've actually recorded all of the transactions that happened as we loaded this page in. So every time that we go to smartbear.com, there's actually 79 calls that have been taking place here. Now, these we can take a look at. We could start to parse through. We could probably cull this down and only utilize our application.json data. But we can actually stand this entire thing up as a mock service. And we'll find that if we now run this, and we navigate to this case, localhost 8080, we should see an actual version of smartbear.com. So it's kind of interesting. It's, we've seen this and we really push this as kind of this API focused thing, but there's a lot of data here that's being captured and that we could potentially be mocking out. So I could now jump in here and start to render out, if we knew that we were going to need to handle some new elements in here, I could force data be pushed, as a new product or something like here. And then we could start to, write tests against it. We could start to build out a front end around it. A lot of ways that we could utilize this. But yeah, hopefully that gives a good example for the discovery feature.
Yeah, I think also, not to throw you on the spot again, we got a couple questions here about Swagger.
Yeah.
So people are asking, can you virtualize a Swagger spec in this way? Does the from Swagger option to create a new virtual server respect the request response models that are defined in the JSON file? Does it also respect the example data, which is exactly what we're doing with our Swagger importer?
Yes.
Let's check this out. It's pretty cool as well.
Yeah, so this is a great question, one of my favorite ones to have asked when we go through Service V. I really like Swagger. I think or the Open API specification. I think it's a great resource and it's something that's really going to grow and scale in the future, especially as we see a lot of services migrating towards REST and further on down the line, potentially something else. But in this case here, we have a definition of what our API can do. We see that we've got some resources on the right hand side. Open any of these up and we have some example data in this case that the API is going to return. Now this YAML file we can actually grab and we can load into Ready API very easily. We can do this through a web call, and we also have, I should have it set up here, we do have an import from Swagger Hub option. So if it's a public API hosted on our Swagger service, which is Swagger Hub, we can search for it. We could also search for it like an organization or a user. But after a couple seconds, this will return a list of all of this case sblib, and we should be able to pick a version and then pull that down to be able to virtualize it. So here we go. And let's grab, I'm trying to remember which was a good one, 2.0. Great. So now that we've imported that document, we can see it's very similar to what we had when we just were initially looking at this. It's a list of all the different resources, the methods, all the different requests that we could potentially be making against this API. And we can now use this as the basis for a mock service. And one of the cool things, and to answer one of the questions, is this actually includes all of our example values. So let's say that we defined, a typical book object in this case. Well, maybe if instead of string, we wanted to actually return some different data. You could go ahead, start to plug in some different titles. You could
clone this down. Copy that too, right? Exactly. So you can quickly add and scale up that data.
Right. So this could be a full, data set that we write out here, maybe, 10 or 15 different responses. We could go ahead and manually set up our parameters here and say, okay, based on my incoming ID, so our path ID is equal to 150. Let's go ahead and return that copy of response 1. Obviously, we probably change the name and everything here. But now the service we can run, we can make some requests against it, and we would find that the ID that we submit actually has like an impact on the data that's coming back. And again, we didn't write any script here. It's not actually reaching out and touching a database and pulling in values, but it is going to dynamically respond. And we can take this a step further. Maybe we run a request that has an ID, and we have that element being returned. We could actually map that value from the request into the response. So again, not an actual API. It's not really doing anything, but it's extracting that value, returning it, and we could start to build some tests around that, validate that that happens, and then when the actual service exists and is deployed, obviously those validations and everything would still be running. So yeah, so it's a really, really interesting way to use the tool. And
you could even hook up like an Excel or a database to that as well, right? So
absolutely.
You could actually just feed in Excel to make all your responses or IDs.
Yeah. Yeah. So that's another good kind of segue here. Let's say that I didn't want to have this bank of responses. Go nix that one. And we wanted some variability here. So maybe this ID, maybe this is something that will change with every new call. It's like a token or something that gets returned. We can actually hook this up to an external data set using a data source component here. We've got some different options, Excel, database connections that we could make. Really simple example, we'll use one of these data generators to spit out our session ID. And we've got some options here. Let's go ahead and set this to a random integer, maybe between, say, 1,000 and 100. Oop. Cool. So now we see getting these random values in. Now from our response, we can actually create a connection to that data source. We can remove any of these hard-coded values. And through a right-click action, we can actually just look at all of those properties that we defined. In our case, we'll grab that session ID. It's going to plug in what we call a property expansion string. This is something that's specific to Service V, Load UI, SOAP UI. It's essentially how we reference data across the tool. But in our case, it's looking at our response at our data source, and it's looking for that session ID prop. Now, when we jump back into our request level and we make some calls, we can see that that ID is now updating. So we get a 506, we get 250. This is just a random value that's being returned, but has tremendous implications. For us to be able to now use this and for us to be able to support something like a random ID, it's going to eliminate, a testing team writing hard set tests, validating against stock data or set data. To be able to implement, this element of change and this kind of dynamic aspect to these APIs, it's going to really, really make a big impact on the way that we work with them.
All right, awesome. Thank you so much. I think that was awesome. There's a lot of questions. We kind of answered a lot while we were going through, but we'll just hit on.
Can I?
Yeah, absolutely.
Just one more thing.
Yeah, definitely.
Just one more thing.
Always one more thing.
Yeah. So up until this point, it's all been happening locally. Like obviously I'm writing, I was writing that script locally. We were running our kind of application locally. Not really the use case in most environments. This happens across teams. We have all of these, different methodologies now for how groups of users work or developers work. So we want to be able to share these mocks around, and we don't just want to share project files. That's a great way for things to get out of alignment. What we can actually do is we can take a local Vert and deploy it to a shared space. There is this kind of sister component to Service V called the Vert Server, which is going to allow us to take anything that's running locally and essentially move it down, publish it to this shared space. And in that way, we could host it essentially for everybody at the organization to be able to use. Our testing teams, our front-end developers, our back-end developers, everyone now will have this mock version, this virtualized instance that they could start to, write integration scripts against, write tests against, whatever it is that they need to do. So very, very powerful piece. And again, is kind of the end stage that we see a lot of teams move these virtual services into. But yeah, that was my one more thing.
All right, let's go through. You see any good ones, PJ, that we can ask? All right, we have one. How does Service V work when you're working with undocumented APIs? Assume the UI is ready and the API is not. So one thing I would say is we definitely can handle when we went through the recording and discovery, that can totally happen on an undocumented REST SOAP call. We're going to be able to synthesize that as it's live, record it, and bring it down actually into a way that almost standardize it, right? I believe we output it in Swagger in the tool itself.
Yeah, we can actually, and it takes a little bit of kind of a workflow thing, but we can essentially write all of our requests to a single project, and then from a project level, we can export Swagger definitions. So we could essentially port something into a Swagger spec through a mock service call. So yeah, it's definitely a possibility.
Yeah, and think of something like, let's say the UI is ready. Let's say it's a welcome screen with a name on it, that the name, a general standard name with, let's say, 15 characters takes up the entire first line, and you've been using lorem ipsum to this point. You can actually use Service V, make the quick mock endpoint that would supply that name, and then data drive the name into there, and then have the ability to just see what different names would look like on your UI. So you'd have the ability to feed it, let's say, a list of 400 different names and run automated tests to make sure that maybe a longer name with 60 characters in it is really going to break up your UI. And that's something that I think a lot of UI teams, a lot of front-end teams are not always looking at, and they don't really have the flexibility of it, right? Lorem ipsum is great, but there's only so much dynamic nature to it. You kind of have to pick a standard name that you think are going to be in the range of all the values that could break. But this really gives you that ability to run the service on the back end and actually give it live data.
Right. And we hear teams come up against that all the time, where they believe they've tested for every eventuality and covered every potential, value and input and everything. And then of course it gets pushed to production and it breaks 2 days later. Someone is using it how it wasn't intended to be used. We can actually, using mock services and virtualization, we can try and eliminate and kind of catch those issues much sooner, especially when we start to think about using something like a data set, potentially a huge data set, and as part of that.
I'm confused about how load testing works with virtualized dependencies. Do you need to configure the virtualized API to be of the same scale, infrastructure quality as the actual service? That's actually a great point. I think there's 2 things we can tackle there. One is that for the most part, when we talk about kind of the load testing against the virtualized service, keep in mind that we're trying to load test against the entire UI with virtualizing maybe 1 or 2 aspects of that back end. And they're generally going to be the most expensive ones you have. Again, things like Twilio that are costing you a real live 2 cents per call. It's really difficult to throw up 500,000 to 1 million VUs in 5 minutes against that and watch your bill climb up. So in that case, we're going to test, we're going to run a load test against the entire UI while just kind of taking that component out itself and throwing in the virtualized piece. So it might not be load testing the actual Twilio service, but it is load testing around how your entire application handles around that.
Right. And the other thing that is a flip side, Twilio takes time to respond. Yep. There's a little bit of a delay. There's a latency in the way that it gets back to you. It's not an instant thing like we've been talking about until this point. We can simulate behavior within the tool. So if we knew that we were paying for a certain size server to be hosted somewhere, we had our API hosted there. Maybe we can expect, X amount of latency, a certain SLA is going to be met by Twilio in this case. We can implement that within this mock service, and when this gets deployed to that shared instance, it's going to carry that through as well. So it will actually simulate some of the behavior of those other services that we utilize in the load test. And as Dan mentioned, the intention is not for us to just load test only the virtualized service. It's kind of a closed loop there. It's to take a piece of the application and virtualize it while we're running the load test. So remove a dependency on something that is costing us or is an issue. That's a cool question.
All right. Any other questions? I'm just going through now. I think anything that's here, we can definitely get back to. There's a lot of questions that I'll probably have to answer back, which we'll get back to you personally. This is awesome. Thank you so much, Nathan. Thank you, PJ. If you guys have any questions, feel free to reach out to us. Visit smartbear.com/servicev, take out a trial, and you can get it up and running and start running those front-end tests with maybe a test complete, Selenium, or cross-browser testing against your new virtualized service. All right. Cool. Thank you, guys.
Thanks, everybody.
Thanks, everyone.